Hey there, I'm going to show you an introduction on how to do distance, rate, and time problems. Now, if you've ever traveled in a car or on the bus, you definitely know what I'm talking about, because when you're traveling in that vehicle, you are traveling at a certain rate, okay? And that rate is usually measured in miles per hour. So let's say that you're going really fast, you're in a car doing 65 miles per hour. That's a distance, miles, over time, hour, right? 65 miles per hour, distance over time. So whenever you have a distance over time, we call that a rate, right? Like 65 miles an hour is a rate. Now, the typical way that you're going to see distance and rate and time problems, they could vary a little bit. I'm going to show you one where the formula is rewritten a little differently. Distance is equal to rate times time. For example, let's say that I was going at 60 miles an hour and I were traveling for 2 hours. Well, you know that since I'm doing 60 miles for every 1 hour, if I'm traveling for 2 hours, then I will have traveled 120 miles. So on a gut level, you already know how to use this formula. You're going to be dealing with word problems, and I want to caution you that sometimes you can get lost in the numbers. Don't. Just take a pen or a highlighter, circle them, highlight them, make them visible, make them stand out so that you don't have to go looking for those bits of information and reread the problem 10 times. Okay, it's a very helpful thing when you circle or identify the numbers in the problem. Now, the final thing I'm going to tell you as a trick for some of these problems, especially the one I'm going to show you, which involves Sandra driving from LA to Mexico and back. In this particular problem, I want you to keep in mind that the distance between 2 points does not change, okay? The distance from A to B is exactly the same as the distance from B to A, okay? And in the video, I'm going to show you exactly how we take advantage of that little fact, okay? Because it makes a big difference in how you use the formula. You might even use it twice. Wonder how that's going to play out. All right, well, enjoy the video, and I'll see you afterwards, and we'll do a little recap and see how it went. All right, take care. Hey everybody, we're going to do a distance, rate, and time problem. I know that you've been looking forward to this all day. No, I'm just kidding. But I know that either way, I'm going to help you out and make sure that you understand the basics for solving a distance, rate, and time problem. First of all, let's talk about distance, rate, and time all together. So the way that you're going to figure out these problems is you first have to know that distance is equal to rate times time. Okay, there's a couple of different ways you could actually write this formula, because you could also say that the rate is equal to the distance over time. And you're used to seeing that, especially when you're in your car and you're driving at 50 miles an hour, 30 miles an hour. That's 30 miles for every 1 hour, distance over time. So 30 miles per hour is a rate. So we can write distance equals rate times time, or we can write rate equals distance over time, excuse me. All right, and either way is correct. Now, whichever way we use for this particular problem, that depends on the problem itself. So let's read the problem together and figure it out. Sandra traveled from Los Angeles to San Vicente, Mexico and back. The trip south took 4.5 hours and the trip north took 6 hours. She averaged 35 kilometers per hour on the return trip north. Find the average speed of the trip south. So Sandra is going for a trip where she starts in LA, she goes south to San Vicente, Mexico, and then back again. The one thing that we know for sure is that the distance is going to be the same. Right? If we go to the place and then we go back from a place, right? That has to have the same distance. So in this case, since the distance is the same, we can use that to our advantage. And this is how you do a problem like this. When you're given time, right? You're given 2 times and you're given a rate. That means that these are going to be part of the problem. So let's say that we have the rate for the trip south, right, is going to be times the time it took to go south, right? This is our southern part of the trip. And then we're also going to have a rate times time for the northern part of the trip. And you may say, well, why are you setting it up this way, man? I totally don't get what you're doing. Well, check it out. We know that rate times time is distance, right? And we know that the distance south has got to be equal to the distance traveling north. So all I'm doing here by setting up rate times time south equals rate times time north is I'm saying that our trip south has got to be the same as our trip north, right? So the distance going south is the same as the distance going north. So all I'm doing is substituting in rate times time in the place of distance. Pretty clever, huh? So let's take a look at how this is going to set up. So I have my rate south times the time going south is got to be equal to the rate going north times the time going north. So we have our setup here. Let's plug in some values. Trip south is 4.5 hours, so we can put 4.5 in here. Let's see here. We know the trip north took 6 hours, so we can put 6 hours in here for our time north. She averaged 35 kilometers per hour on the return trip north, so that's our rate, 35 kilometers per hour. Of course, this is in hours, this is in hours. And it's important that you make a little check here that the units are going to be the same. And if you have kilometers per hour here, you want to make sure that if there's hours in the bottom, that you have hours here as well so that they cancel. Every once in a while, math teachers like to play games and be silly. They put hours here and minutes here, so just watch out for that. This is a teaching moment here where I'm just giving you the basics, so I'm not going to be very tricky when I show you how to solve the problem. Alright, this is our setup. The only thing that we're missing is the rate south, which is what the problem asked for. So our rate south times 4.5 is equal to 35 times 6. So to get the rate south by itself, I'm going to divide both sides by 4.5. The rate south is going to be equal to, drum roll please, 35 times 6 divide by 4.5. And there you have it, 46.67 kilometers per hour. Thank you very much. And we are out of here. Alright, so there's our answer. And you can see how we set it up. Very slick. Rate times time is equal to rate times time. Why? Because the distance south is the same as the distance north, right? Going from LA to Mexico, Mexico back to LA. That's all I got for you in this video. Watch another one if you need more help, and I'll see you next time. Alright, so you got your dose of distance, rate, and time, so that's the end of our problem for today. Remember my tips. Remember the formula can be rewritten in a number of ways, but the first way is that distance is equal to rate times time. And make sure that when you're dealing with these word problems that you take the time to circle or highlight the numbers that are built into the problem. That will save you time when you have to go back and find them for plugging them or substituting them into the formula. Okay, that's a very important point. So circle or highlight those numbers that are part of the problem. By the way, that also includes numbers that may be written as words like 16, S-I-X-T-E-E-N. If you see words that represent a number, then it's helpful to circle that and even write 1/6 above it, so that way it even stands out further. All right, my final point is that the distance between two locations doesn't change. So the distance to a place and the distance from that same place back again is the same. And you can use that to your advantage, especially when it comes to solving the problems and using algebra. All right, that's all I have for you right now. And if you need more practice, watch another video. Otherwise, I will see you next time.